Hi, okay, welcome to session 10. I know I'm invisible at the moment. The recap's quite big and I'm probably just better not on the screen just for the moment. So there is quite a lot here. It may even feel like a bit of a session all by itself. We're also going to be looking at trig throughout this video, and it's like everything to do with the basics of trig. So our SOHCAHTOA right angled triangles. There is advanced trig, but that goes into our higher GCSE, and we're sticking with the introduction of trigonometry in this session, but it is big. Okay, we would normally spend 3 or 4 lessons in the classroom, so please don't think you've got to do all this recap and sit through this entire session in one go. It would probably be way too much, so be sensible. I'm going to do the norm, scroll through the answers, and then we will get going. Okay, so okay, so hopefully that went well. You've taken the time to pause and mark and look at the workings out for anything that did go wrong, so that you've got those corrections. The only reason that I highlighted this question 4 part 2 was just because that middle term disappears, and if that had gone wrong, you might have needed to see how it disappeared. So I really just wanted to highlight that, but hopefully it didn't pose any problems. All right, let's get into this. Trigonometry is all focused around the right angled triangle. Now, there is advanced trig with some bigger formulas that you'll see later on in higher courses if you study that far with us, but we're just focused in on the first level of trigonometry. It starts at grade 5, so this is crossover for both higher and foundation GCSE. So let's get started. This SOHCAHTOA is something that helps us get, sort of select the right function. So there's 3 functions that you have on your calculators. You've got sine, cos, and tan. So you've got those buttons on your calculator, and those are kind of linked to the angles. So the S, C, and T in SOHCAHTOA is sine, cos, and tan on your calculator, and it also includes the angle. So let's just talk about the angle. So I've got the angle marked here as theta, the Greek letter, which you may or may not see in textbooks, in exams, and so on. There is always one acute angle that is either marked up, because we've got to work out what it is, or given to us, like 52, 53, whatever it might be. And that will be part of our problem solving. And it lives here in the formulas that I'm slowly starting to build for you. The OH, AH, and OA that you see attached to sine, cos, and tan are actually coming from the edges of the triangle. Okay, so we have to label the triangle really well, or it goes wrong before we've even started. So the labeling is probably more key than anything else, because if you don't understand this step, you will go wrong constantly, and it will be a very frustrating topic. So this is how we do it, or this is certainly how I do it. I do the same thing every time, so that I am in a routine, and then I just flow through every diagram in the exact same way, and I don't have to think about it too hard. So I go to my acute angle. It's either marked with a theta or an X or a value. I see that first, and then I travel across the triangle to the opposite edge. So this edge and this edge make the angle. I want the opposite edge. Okay, so I travel across to this edge and I label that O for opposite. The next one I do is the hypotenuse. The hypotenuse is always opposite the right angle. So there's my H. And then that leaves my A. A stands for adjacent, adjacent being side by side. So this angle is resting against this side, if you like. So it's resting against the hypotenuse and it's resting against the adjacent. So I will always go OHA. And then the way that we select things. So if I've been given this side, well, that's rather thick. And that's rather thin, one extreme to the other. If I'm given those two signs, then I've got O and I've got H, which means I have O and H together. So it would be telling me to use the sine. If I had this edge and this edge, I've got O, A and H together. That would be telling me to use the cosine or the cos. And the last one you can kind of see would be O and A, creating that one there. So to finish off our actual functions, sine theta is equal to opposite over hypotenuse. Cosine is cos theta, A over H, and our tan is opposite over adjacent. And that's why we learn this as a shortcut to finding one of these. One of these is going to solve the problem. Now, at the moment, you don't really know what the problem is because we haven't gone that far yet. But as I say, the most important thing is being able to label up those sides, because you can see if you get it wrong, you're just going to end up picking the wrong one of these, and the wrong one of these will give you the wrong answer. So I thought the first thing that we should do is actually practice labeling those sides. Okay, so I want you to press pause and I'd like you to hit play when you have finished putting all the O's, A's and H's everywhere on those diagrams for me. And there's your answers. Okay, so whatever works is what you should do. Like I say, you could really do that one very easily first. Get that O marked in. Like I say, I like doing the longest side after that. So for me, the next obvious one is my H, and then my A is just left to be done. So hopefully that has gone well. Every single question that we do is going to require this. So even if you've got the odd one that's gone wrong, it's not going to matter because we're going to be practicing it on every single question. So let's go back up and actually see this whole thing in action. So I am going to keep this. I think I'll just pop it a little bit out the way, and then we'll clean up and put a new triangle in. So here's our first question. So looking at the triangle, we've got the acute angle marked. They've actually given us a value, and we've got the hypotenuse given to us, and we have to find this side. So we're working at the moment on finding missing lengths. So first job, always get the edges labeled. And I really want you to hit pause and label that. Don't just watch me, practice every chance you get, label that, and then press play. Okay, so hopefully you've got your O, your H, and your A. Now, looking at the diagram, I can see that this edge is really important because it's got a value on it. This edge is really important because it's the edge I'm trying to find. So A and H are the two important edges. So I write down SOHCAHTOA. Write it every single time if you want this to go into your head every single time. I've got A and H, which is that one there. So it's going to be cos theta equals A over H. I'm literally writing it in the order. C first, cos theta, A on the top, H on the bottom. Once I've selected my function, I go back to my diagram and I start transferring the information from the diagram into the function. So I've got cos. Now I don't need to write theta because I've been given the angle, it's 42. That is going to equal A, which is labeled X, and H, which is labeled 12. Now, if I want to know what X equals, I have to get it on its own. If you've done any work with me at all, you must have heard that 100 times. So if you want to know what X equals, you get it on its own. We hop anything that's with the X away from it. So I'm picking up my divide by 12, and it's going to land over here as times by 12. And that is basically what I now put into the calculator. It's basically all it is. I'm going to put 12 times cos 42 into my calculator. My calculator is going to give me 8.91 and on and on and on it goes. I'll round to whatever I'm being told to round to. So we'll round to 1 decimal place. And job done. That missing edge is 8.9 in length. All right, so you've seen it work through the one time. So let's do another one. So I want you, let's get some labeling on. Some units on this time as well. And we'll go 30 degrees on the angle. So what I'd like you to do this time, using the note from the previous question, I'd like you to hit pause, and I genuinely just want you to go as far as you can. Now that might be just to the labeling stage. It might be to labeling and choosing the sine or the cos or the tan. It might be going all the way through and getting a value for X. Everybody learns at a different rate, and you've just got to do what's right. So all I want you to do is pause and take this as far as you can, bearing in mind you've only seen it once. Okay, then hit play, and I'm going to talk you through the whole thing. Okay, so labeling the sides. I've got O, H, and A. I'm going to write down SOHCAHTOA, write it down. Don't just glance up at your notes because you've already written it down. Write it every time. We need that in our brains to retrieve the minute we need it. Okay, now what are my important sides? This is important because I've got to find it. This is important because it's got a value on it. So H and O. O and H are here, so that's the function. So I'm going to write this out in full. And again, I'm not taking shortcuts. I'm not being lazy. I want to learn this. I want it to go into my head. I'm going to write it out every single time. So now I'm taking the information from the diagram and I'm putting it in each of these positions. So sine theta is the angle. The angle is 30. O is the opposite. That has an X on it. H is the hypotenuse. That's got 14 on it. I'm going to pick up my divide and it's going to land as times, and 14 times sine 30 needs to go into the calculator, and it equals So my x equals 7 centimeters. Okay. So it doesn't matter whether you only just started the first bit, you are just starting the topic. So all good. If you actually managed to get all the way to the end with that, absolutely fantastic. Really, really well done. So we're going to do another one, and we're going to do it in exactly the same way, where I'm going to ask you to just hit that pause button and just go as far as you can before you have to hit play. Okay. So we're going to say we've got 8 centimeters, and we'll call that one 23 degrees. So hit pause and press play when you're ready. Okay, so labels. I've got my O, my H, my A. What is important to me? I've got an 8 for that edge, so that's important. That's important because it's the side I need to find, and that is an O. So write out my SOHCAHTOA. I need O and A, they're together here next to the tan function. So it's tan theta equals O over A. Now go and get all the information from the diagram. The angle is 23. The O is X. The A is 8. If I want to know what X equals, I'm going to get it on its own. So that's going to land as 8 times tan 23. Put that in my calculator, and it tells me that X is equal to 3.395. On and on it goes. If we round that to 1 decimal place, it would be 3.4 centimeters. Okay, hopefully, it's starting to all come together. All right, here we go. Next question. We're gonna, oops, a bit wibbly wobbly. I'm going to say that that angle there is 27 degrees. We're going to look for that one. And we're going to know that that one is 5 centimeters. Okay, so that's everything in the diagram. So hit pause, go as far as you can, and hit play when you're ready. Okay, so my opposites over here, my H and my A. The two sides that are important are these two. That's O and H. O and H is the sine function. So I've got sine theta O over H. Put in the information, sine, the angle is 27, O is 5, and H is X. Okay. Everything was normal. Everything was as we have seen it up until this point. But now what's very different to this than to your other questions is that the X has ended up becoming the denominator. In all our other questions, the X was the numerator, and then we just picked up the denominator and we multiplied by it. We still have to pick up the denominator because it's the only thing available to us to move. On this side, we've got 5 divided by X. The divide lives with the X. So I can't take the 5 over because I can't just leave a denominator. So I'm going to show you what's happening mathematically, and then I'm going to show you the shortcut, okay? So we've got sine 27 equaling 5 over X. I can't move the 5, so I'm going to have to move the X. So X is going to land as X times sine 27. So I've now got sine 27 equaling, oh, sorry, X times sine 27 equaling 5. Now that hasn't exactly got X on its own, but what it has done is it's brought the time sign with it, And that can now be used with the sine. So I can pick up my times by sine 27 and I can drop it and it'll land as a divide. So what ends up actually happening is they swap places. The sine 27 ends up as the denominator and the x ends up on its own on the other side of the equals. And that's kind of the shortcut. There's nothing wrong with doing it by hand completely and in full. Obviously, that is the maths that's happening. But if we can see that a denominator is the variable we have to find, is the letter, then it makes sense to just quickly switch places and it's job done without too much aggro. So x is going to equal 5 over sine 27. You put that in your calculator and you got 11.013, it goes. Now, if I was to round that to one decimal place, it would be 11.0. And lots of people don't want to show that 0 because it's got no value. So you might as well just write 11. I don't disagree. However, if the question says round to one decimal place, it doesn't matter whether there's a digit with value or without. You have to put something there. So in this case, it would be 0 and centimeters is the answer. So you might want to add into the notes that you're making this little thing here. All right, so it's really clear and you've got something to look back at and to remind you that when x is the denominator, it switches places with the sine 27 or the cos or the tan, whatever's there. All right. Okay, let's have a go at another one. So there's our triangle. There we go. So pause, go as far as you can and press play when you're ready. Okay, so opposite, hypotenuse, adjacent. I have A that's important and I've got H that's important. I'm still going to write it out in full, so I never forget. SOHCAHTOA. I have my A and H, which is that one. So it's cos theta A over H. Go and get the information. Cos 56. A is 9. H is x. X is the denominator, so they are switching places. And I will end up with x equaling 9 over cos 56. When I put that into my calculator, I get 16.094 and on it goes. Round that to one decimal place, 16.1 centimeters. So hopefully it's all going well. Okay, let's do another one. If you're getting them right and everything's going really, really well, and you don't feel like you need to watch more examples, you can always forward on to the exercise or go to your booklet and start the exercise there. I don't think you can ever do too many, if I'm honest. It really is nice just having the questions that you're doing worked through, and that's the point of this, so that you've got lots and lots of different examples that you can try, but that you can also get the full working answer against. So there you go. That's your next one. Hit pause, try and get a value for x, and then press play when you're ready. O is important, H is important, so it's sine. So sine theta is O over A, sine 50. O is X and H is 10. This is a nice one. It's not a switching of places because the X isn't on the bottom. X is the numerator. So my 10 is literally just going to go across, land as times by 10, and then I can just stick that straight in my calculator for my answer. So my value of X is 7.6604. On and on it goes. Round that to 1 decimal place, and you've got 7.7 centimeters. So well done if that went the way you wanted it to. All right, our next one. We're going to have 71 degrees, X 6.8. Hit pause and press play when you're ready. Okay, so sine has been selected. And we've got sine 71, opposite 6.8, H is labelled X. X is the denominator, so we're doing a switch. So X, it'll be there, and it'll equal 6.8 over sine 71. Pop it in your calculator, and you get 7.1918, and on it goes. So we've got 7.2 to 1 decimal place. I didn't give you any units, so we don't put any units. All right, I think we'll do just one more, and then it's a case of practice makes perfect. So okay, so we've got 58 degrees, 17 centimeters. Hit pause and press play when you're ready. Okay, we've got A and H. So it's the cosine rule. So cos theta A over H, cos 58. A is X, H is 17. So this is another one where I literally just move the 17. It lands in place. Pop 17 times cos 58 in my calculator, and it tells me that X is equal to 9.008, and on it goes. So to 1 decimal place, 9.0, and that'll be centimeters. Okay, so that is using SOHCAHTOA to help you find the missing edges of triangles when you've got an angle and one other edge. If it's going really, really well, then well done. All right, keep practicing. The one thing that I would say about this is because it's coming quite late in the course, it means that you're not going to see as many recaps as if it had come at the beginning. So the amount of times you revisit it with me personally won't be a huge number. So it will be really important for just training that brain, creating that memory recall to be dipping into this type of work as regularly as you can. So you've got the questions in the worksheet, and I'm going to scroll through them slowly in the normal way. Then I will scroll through the answers, and then I will show you how we use exactly what we've been doing to help us find missing angles. So everything we've done has been on edges. The next session, which is just going to roll up after these answers, will be on the angle side of things. and onto our missing angle. Now, what I want you to do is have some faith in our method. We teach formulas so that they work even when you have got something that you might not be quite so familiar with. So I'm not saying that you are necessarily going to know exactly what to do and you should get the answer right, but you should know how to label it, and you should know how to choose the function, and you should know how to transfer the information into the function from the diagram, etc., etc. So hit pause and press play as soon as you are, ready. You've got to that stage where you think, okay, I've got that far, but I don't really know what to do next. So hit pause and press play when you're ready. Okay, so we have got SOHCAHTOA, label, O-H-A. These are my important ones, which is O and H. So getting the information, I go to the angle and it's X. It's not a value, so I will put X in. O is 6, H is 11. Now that's as far as you may have got, because actually now you're about to do something that you may not have done before. I still have to get X on its own. If I want to know what it equals, that's what I do. Nothing has changed there. But I also know that when I'm taking something over the equal sign, it changes, doesn't it? If I take an add over, it lands as a take. If I take a times over, it lands as a divide. Well, I'm going to be taking sine over the equals, okay? So I'm going to be picking up that, not the whole of sine x, because I want to leave the x, just sine. And I'm going to be popping it on the other side. It's got to land as something different. So what I want you to do is I want you to take a look at your calculator where your sine, cos, and tan buttons actually are. And if you look just above them in yellow, you will see that there's the words again, sine, cos, and tan, with a little -1. And that is the opposite, the inverse function. So you need to use your shift button when you want to use the inverse. So when this sine lands, it will leave X on its own. You then write the sign, so it lands kind of in front of the fraction with its -1. That's really important. The calculator is going to automatically open up a bracket. So it's good practice to just show that, I think, and then closing your bracket. And that's what you end up typing into your calculator. So you're going to press the shift button and sine. That will bring sine -1 up onto your screen. It will open a bracket. You can then either put the fraction key and 611 in, or just write 6 divided by 11. So what I mean by that is you've got a fraction key that you could then hit, put the 6 in there, put the 11 in there, and close up the bracket. Or you could just accept that 6 over 11 actually means 6 divided by 11. So you could type in your sine -1, it will open that. You could then just go 6 divided by 11, which is a bit quicker, to be honest, than using the fraction key. Close the bracket, press your equals, and you will get 33.0557, and on it goes, coming out. Okay, rounding that to 1 decimal place is 33.1, and of course it's degrees because we're finding a missing angle. So that is it in a nutshell. You are not learning masses and masses more. You are simply learning to do exactly what you did, but to get X on its own, you will be moving this function, be it sine, be it cos, be it tan, and it will land as its opposite. And that's the only thing that's different. Absolutely only thing that's different. Okay, so let's clean this up and give you one to have a go at. Okay. There we go. So we're going to put 6.8 centimeters here. We're going to label that one X. That's one I want us to find. 14 centimeters here. I want you to hit pause, have a go at getting the value of x, and press play when you're ready. Okay, so let's label these sides. Haven't done that yet. O's over there, H and A. So my important sides are A and H. They're the ones with some information. So that's cosine. So we've got cos theta is A over H. Now go and get the information. Theta is marked as X. A is marked as 6.8. H is 14. That's going to move across, leaving X on its own. It's going to land as cos minus 1. You've got 6.8 over 14. You put it in your calculator and you get 60.9407. On and on it goes. Now, if we're going to round that to one decimal place, it'll be 60.9 degrees. And if you got that right, brilliant. All right, you've already got it sussed, so well done. It's just that little change at the end, so don't try and like think it's more. It really is the same that you've already secured when you were finding the edges. So we'll put some units on and we'll say we're going to look for that angle. So hit pause, press play when you're ready. Okay, so we've got A and H. So it's cos again. Okay, theta is labeled as theta, so we'll keep it. A is 14, H is 23. Move cos so that what we're looking for is on its own. That is going to land as cos minus 1, and then 14 divided by 23. Put it in your calculator, and you get 52.5047, and on it goes. Okay. We want to round that because it's an angle. Angles generally are rounded to 1 degree, whereas lengths can be 1 decimal place, 2 decimal place, or 3 significant figures. There we go, 52.5. Okay, again, as I said last time, if you are finding it really straightforward and easy, you don't need to listen to any more examples, then obviously go straight back to the exercise. What I've done for the exercise is a mix. So you might be finding a missing edge, and then an angle, then an angle, then an edge. So it's just everything all in one exercise. I am going to do another 2. So if you want to just do those and have it walked through to the answer, so you know what you're doing and what you're thinking is really secure, then obviously don't be racing off. Stick with me and we'll do a couple more together. So we've got 12, 9.2, and you can find me that angle. Okay, so hit pause and press play when you're ready. So this one's tan, because I've got the O and the A. So tan theta is O over A. Tan, and it's still theta. O is 9.2, A is 12. Obviously, tan isn't going to move across this time, leaving theta on its own. It's going to land as tan minus 1. 9.2 divided by 12. Put that in your calculator, you get 37.475. On and on it goes. and you've got 37.5 degrees. Okay. So well done for that one. And we'll just do one more together before I leave you to it. So, I'm not very original with my units, am I? They're always centimeters. Okay, hit pause and press play when you're ready. Right, O and H, so this is a sine. So we've got sine theta is O over H. From the diagram, theta is X, O is 7, H is 13. Sine is going, leaving X on its own and landing as sine minus 1. We've got 7 over 13 going in to the calculator altogether, and you get 32.578, and on it goes. So to one decimal place, 32.6 degrees. Okay, brilliant. That is trig. That is trig in one video. So we use it to find missing edges and angles of right angle triangles. Really important that there's a right angle. Okay, and then obviously once we're really good at the skill, then we start learning how to apply it to maybe wordy questions or something along those lines. All right, let's put the next round of questions up. Again, I'll do the scrolling through slowly on both these and the answers so that you can pause and play at the easy and appropriate time for you, or be using your workbook. And I will see you next session. So really, really well done on this trig. It's a big old topic.